Today we'll be doing an Introduction to Git workshop. I'm actually going to stay out of present mode and just reference the slides here because I will be doing a practical demonstration, so we'll be spending a lot of time in the terminal. I want to start with a little bit of motivation. So what is Git? It is primarily two things. It is a version control system, which means that you are able to save snapshots of your work and allows you to do versioning in a much more convenient and clean way than the classic. And I'll show you pictures, examples of that later. It allows you to manage code. The primary use of it is in classic code like web development, JavaScript, HTML, Python, Java, C++, you name it, it's for classical programming languages. I'll show you an example later of a maybe more obscure way of using it that we found really useful in PIB and encourage you to use as well. Why, though, should you learn Git? And beyond the version control, it also allows you to collaborate. It's extremely inefficient to share code files by emailing them or what have you. And instead, by using Git, you can very easily collaborate with people. That means working in different files or even the same file simultaneously without any overhead or lag time of these less preferred collaboration tools. You want to be good at collaborating or efficient with collaborating because it is very common in industry. If you want to work with any software, I have yet to find a position that doesn't have some kind of version control in the job description. Perhaps it's not Git, there are other options, but potential employers want to know that you are able to collaborate because you're never going to be working on your own. All real projects are going to have an interdisciplinary team that you need to be able to work with. Now, one of my main claims here is that Git makes technical collaboration efficient and easy. And to prove that, I want to show you an example of how people used to version things. I'll go into present mode for a moment so that you can see this picture here. Versioning can be different files where you make minor changes and you have some kind of hopefully consistent numbering scheme to keep track of them. This is messy, wastes space, and is hard to keep consistent. So what Git allows you to do is instead you track changes in files rather than entirely new files. This makes it so that you're not repeating files. It takes care of everything in the back end for you. Another really good advantage is that when a team member is absent, say you have someone who has made 3D models and you're using GitHub to store your SolidWorks files, if one member has those files and they are absent at a meeting, the entire meeting can be made useless if you guys can't move forward without them. By using Git, everyone has access to all files at all times, and if you use it properly, it'll be the most updated version of that file. And regardless of who is absent, you will be able to be productive. Finally, it keeps your work safe, so to speak. It keeps a history of your project, such that if you really mess something up or otherwise want to return to a previous state, you can easily do that. So there's no fear of things breaking or being lost somewhere because everything has multiple and consistent backups. I'm going to exit back out of full screen mode because it's actually time to get started. So depending on your operating system, Linux, you install things as I'm sure you're used to installing things. Mac should actually have it already, so I'm on a Mac computer, and I'll show you that it comes pre-installed. Go ahead and run that just to check it. It's okay if your version isn't the same as mine. Windows is not very terminal friendly, so I need you to go install Git Bash and make sure when you open it, you use Git Bash. There's another option like Git Command, Git Shell, something like that. That's not going to have the commands we need. Git Bash is going to enable you with a lot of Unix commands that are comfortable for Linux and Mac users. So pause now, take a moment to get that installed if you're on a Windows computer. So to get started, what is a repository? A repository is just Git's name for a directory, and a directory is a folder. So if I open Finder, which is the file explorer on a Mac, and go to my user, right now I have it so I see hidden files, but this shows me everything in my home directory. Terminal allows me to do the same thing. If I do pwd, that shows you your path, and I'm currently in my user. And if I do ls, I don't know what it stands for, I think of it as list, it shows all of these same files and folders. So this is just like the computer power user's way of exploring or using the file system. So I'm going to go ahead and close this, and we want to make a folder for our project to exist in. You can make it wherever you want. I personally have a folder called Git for all of my projects. So I'm going to do make dir git tutorial to make a new directory, and then cd to move into it, If you just type the first few keys or characters, you can then tab to autocomplete. And if I do pwd now, we can see that we've moved into this folder. Right now, what this is a directory. It has nothing to do with Git and is therefore not enabled with the powers that Git gives us. So if we run git init, it will say that it initialized an empty Git repository, and we can ls-a to see hidden files, and it has created this .git folder. This is where all of the Git information is going to be stored. So as you're creating files, moving things around, you're not going to see it because it's a hidden folder, but as you make commits, that's where everything gets saved, and it's all hidden inside there. So now if we ls, this folder is empty, we want to create a file to save. So I'm going to use Vim. It comes pre-installed on a Mac computer. Linux, I trust you know how to install it, and you should have it on Windows computer with Git Bash. So Vim and just file.txt. Vim is its entire own area. I'm not going to try and teach it to you. Instead, for this specific example, just follow my exact keystrokes. The first thing to notice is that Vim has two modes, or three modes. We're going to use two right now, where you start in command mode. So if you type at the moment, nothing's going to happen. You have to enter insert mode. So you can press A or I to do that. And you'll notice down here, it enters insert mode, it tells you. And now we can type something. So let's just say, I am learning Git. Now, press escape to enter or go back to command mode. And you'll notice the insert tag went away here. And to save and close our file, you need to press :WQ, and down in the left, it'll show you what you're about to execute. Press enter on that. You should return to your terminal or command line, and ls shows us that we have created this file. We can now use git status, which shows us that we now have this file, and it is untracked. That says that Git knows nothing about it, and as you make save points, it is not going to be used. So at this point, we want to introduce our file to Git. And we're going to take a minute to talk about how Git works. I'm going to go back to present mode. And this image on the left is an example of the versioning that I told you about earlier. This is the alternative to that long list of different files with their version numbers. Instead, you keep all of your original files, and what Git tracks in its commits are the modifications and additions. We can think of this like a video game where we have these save points, and nothing in between the save points is kept. You only have the state of your project at the point that you make a save, or in Git speak, when you make a commit. This image on the right shows the structure or the areas of a Git repository. You have your working directory. This is the current state of your repository. It is all of the changes you have made, the instantaneous state of your project at any given time. The local repo is where all of these saves are. So the local repo is going to be at the most recent commit that you've made, and it's what Git knows about your project. This staging area in the middle really gives you fine control over what goes in your save. And it might seem super flouce if you always want to save everything, but since what we're working with is code, that's not always going to be the case. Say you have two different files, and in one file, you're in the middle of implementing something, and it actually doesn't even compile right now, so to add it to your project would break it. But you've made a functional change to another file that you do want to save before it possibly or potentially gets messed up. The staging area allows you to specify to Git that when next time you make a commit, you only want to save that file that works, and it's going to ignore the changes to the file that you're currently working on. So the staging area allows you to have the fine control that as a programmer you're going to need. And now let's actually do that. First, take a look at these lines on the right here, the error handling. When you make a commit, Git saves who made it and the email that goes along with it. This goes back to collaboration, where when you see a particular change, you know who to talk to if you need to ask clarifying questions about it. Execute these two lines real quick. It actually doesn't really matter what you put. All it uses them for is to add information to the commits, but it'll give you an error later if you don't do it. So take a moment now to enter those. And when you're done, we can execute these commands on the left. So git add puts things into the staging area. That's when we went back here. It's taking it from the instantaneous state of our directory to prepared to be saved. You can specify the file that you want to add, so I could write file.txt and it would put file.txt in the staging area. But a lot of times, I actually do want to just add everything that I've changed. And a shortcut for that is dot, just for local directory, it'll add everything. And if we run git status again, it'll now show us that we have a new file that is prepared to be committed. The next line actually makes the commit, and you always want to do this -m and put some kind of meaningful message that says what you've done. In this case, we created a file. Execute that, and you should be told that you created a file, so create mode, which with one insertion, which is because we had one line in the file. At this point, you might be told to enter these lines if you didn't use it earlier. Go ahead and take care of that. And now we can do git log. So this is the record or the history of your project. We can see now that we've made a commit. It tells us who created it. Wig and wannabe is what I gave it when it asked for my name originally, and the email that I gave it as well. And it lists your commit message. The reason your commit message is important is because you can actually return to earlier points of your project. So say I am a dozen commits from now, and for some reason I want it to come back to this point. If I put a random message here, I would have no idea how to find it. So meaningful git messages or meaningful commit messages permit you to track a real history of your project. That's how we use Git locally on our machine. But we talked about how Git is really useful for collaboration. And to do that, we need to learn about local and remotes. So I'm going to go back into present mode, walk you through these images, and this might be my favorite infographic ever. We are all code monkeys. And as the code monkey on the right, I'm making changes to my files, and my collaborator is making changes to the project at the same time. We're working on different pieces of functionality or maybe different pages. We each have copies of the local repository, or we each have local repositories on our computers. The way that we share the project is through the remote repository. All this is a home for our project in the cloud, and we interact with it by pushing our changes and pulling other people's changes. So this is just the link between our local repositories so that we can all work on the same material. And what we want to do next is create the cloud repository and then link it to our local repository so that we can interact with it. And the way we're going to do that is this command here. Remote tells us that we're working with the cloud repository. We're going to add it, and we're going to tell it that it's the origin. The reason we have an alias is that you can actually have multiple cloud repositories that you sync to, and you can specify which one you want to send these changes to. Possible use case for this is your hosting service, where you can say that your origin is going to GitHub, but when you want to deploy a new version of your website, if that's what your project is, you could instead, say your hosting service is Heroku, add a Heroku alias, and then you could push your changes to Heroku instead. To do that, go ahead and go over and make a GitHub account. I already have myself logged in over here. It's a very fast installation, so take a moment to create one if you don't have one already. Once you're logged in, click on this Add button in the top right, and we want to make a new repository. I'm going to make Git tutorial. I get to autofill because I've done this workshop a few times. We're going to keep it public right now. To use private repositories, you do need a paid account. However, they have a student plan that allows you to have private repositories while you're a student. So if you create your account with your ucsd.edu email, you can get free private repositories, and I highly recommend that you do it. For now, though, we're just going to keep this one public, and make sure that you do not check this box. We do not want to initialize with the README. Go ahead then and create repository, and it's going to take us to the home for our project. Since there's nothing here right now, all it shows is this Get Started page. Go ahead and copy this line here, because we're going to use it in a minute. Now our cloud repository exists, so we have a remote, and we have our local repository, and we need to permit them to talk to each other. We're going to do that with git remote add origin, and you're going to paste the link we just took from the cloud repo. Go ahead and enter that. If you're on a Windows computer and you're using Git Bash, to paste, you can double-click and select paste. Your keyboard shortcuts actually aren't going to work, unfortunately. Now that they're linked, we can push the state of our local directory to the remote. Going back to our code monkeys, when we have changes on our machine that we want to put to the cloud, we push them. So you can say git push origin master, where master is our branch, and I'll talk about that briefly in just a moment. It'll take a moment to do this. You need an internet connection for it. The rest of this actually could have been done offline, but of course you need an internet connection to push to the internet. And if we refresh our page, we now see our file.
Calling Mrs. Really Ice Keith, and I'm here helping Stas with the Git tutorial. So here's my GitHub. Let's go find Stasia. So I follow her, so I can go straight to her GitHub. And here, if we go to her repositories, we have our Git tutorial. So today I'm going to be collaborating with Stas to show you guys what it's like to work with a collaborator. So we see that you guys already have the file. So to get started, go to wherever you want to start your Git repository. Stas uses the Git folder. I use one called projects because it's where I do all my projects and have them all using Git here. Alright, so the first thing we're going to do is come to our repository and go to this green button that says clone or download. You can click on this to copy the link. It was really easy to clone this one and quick. If you have larger repositories, it may take a couple seconds. So we're going to do ls, and here we see Git tutorial. So let's go ahead and change directories into that and see what's inside. You'll notice this is exactly what you guys had working on Stas's computer earlier. Let's verify the contents of file using cat, and we see that it says I'm learning Git. So it's exactly how you guys left it. So let's go ahead and open it up and make some changes. So it says I'm learning Git. Let's go ahead and put, yo, what up, nerd? Just a Git collaborator doing work. Yo. Awesome. And then let's get out of here. Escape, :W save, Q quit. And if we do git status, we can observe that we haven't staged our changes yet, but you see that we modified file.txt. So let's go ahead and add that. Git add dot git status again. It's in the staging area and it says we modified it. Let's go ahead and give it a commit. Here we modified, or we'll just put modify file.txt to show how collaborations work with Git plus GitHub. Good. We can go ahead and push that now. Just want you guys to observe that it says 1 file change and 2 insertions. That's because if we cat file.txt, we see that we added 1 new line and then our second line here. So let's go ahead and do something else before we pass it back to Stasia. Let's go ahead and just make a new file. So we can do vim file collaboration.txt. And in this file, let's just put this is a new file to show that we are adding to the, or that we are creating something new for the repository. Good, we can exit out of there. Once again, we'll go through the full steps. Git status, we see that now we have 1 untracked file. This was different than before when we were just making changes to another file that we already had in our repository. This is showing that we actually don't have this in the repository yet. We can do git add dot, git status one more time, and we see that it's a new file. Before it said modified, so we're adding something to the repository, and in stage, we do git push, or sorry, git commit m, and give a new message. So add new file to demonstrate collaborating. You get push origin master. Notice before we hit enter, it says we added a new file. 1 file changed and 1 insertion. Create mode. We can do get push origin master. All right, so only take a moment. There we are. We do get status again. Nothing has changed. We can do get log. We can see both of our commits that we did. And if we go back to the web page, we can see that we added a new change and added 2 commits, and we have our file with our 2 new lines, and we have our new file with the line that we put in there. So it's all ready to pass back to Stasia. See you later, nerds.
This just in, Colin tells me that he's pushed something, and I can see it here on the remote. So I'm going to go ahead and pull that down. Over here in my terminal, we can see I'm still in our directory, and I can say git pull origin master. Again, this is saying that I'm using the alias origin and I'm pulling the master branch. Branches are a way for us to break up our project. So say you're embarking on this huge new experimental feature that you're afraid could completely break your project, but you want other people to be able to keep working on it because maybe they're just doing bug fixes or smaller features. You can make an entirely independent version of your project called a branch and do it. And you could name that something else and you can commit them separately. So I could say git pull or git push origin new feature, and it would only change that one while not affecting master. Right now, all we have is master, and what we want to pull is master. So we're going to execute that, and it tells me that you changed new files, or you changed 2 files, and you made 3 insertions. In file.txt, you added 2 lines, and in file collaboration, you added 1 line. If we do ls now, we see that we have obtained your file, and I can cat file.txt, and you added this line, and let me go ahead and cat file collaboration, see what you sent to me. We can also do git log, and in addition to the commit that we originally made, I can see your 2 new commit messages. So with pull, we have completely synced up my collaborators' changes. Let's go ahead and finish up our presentation now. Last thing is, if you are in a hands-on class at UCSD, then your submission for this workshop would be to send us the link to the repo. If you're just watching this to learn, clearly you don't need to submit anything, but I want to talk about these going further checks real quick. Git checkout is a particular command. That's what I was saying earlier, where you can return to earlier states in your project. So if I wanted to say check out your first commit, I can say git checkout and then put this just first few characters in the commit ID. And now it tells us that we have detached our head and that it is at modifyfile.txt to show how collaboration works with Git and GitHub. If I ls at this point, we can see that we are at a point in your history before you made that Git collaboration file. Now we want to go back to master. So let's say git checkout master. And now we should be back at our original point. And if we git log, our head, which is the current state of our current position of our directory, is back at that most recent commit. The other topics here are merging branches and commit and conflicts. I just told you a little bit about branches. When, say, that experimental new feature is done and you want to integrate it back into your master branch, what you do is perform a merge. So you'd want to learn about merging once you get to that kind of advanced usage. Another place that merges come up are when perhaps your collaborators have changed the same file. Right now, I changed the file and then Colin went and changed it, but if it were a larger project, he and I could have made different changes in the same file if we were working on different parts of it. And Git is really good at splicing those changes together to integrate them when you push and pull. But if you guys made changes that were ambiguous, say you edited the same line, if Git doesn't know what you wanted, or if it's ambiguous at all, it will not make a decision. It'll tell you to make it by creating a merge conflict. And when that happens, it puts markers in your file on where the conflict was, and you have to go fix it and commit the fix for it to complete the merge. What you do at that point is actually talk to your collaborator. You guys will probably have to sit at the same computer and look at the file to decide what you want to use. And once you've unified the file into your final version, you can tell Git what you ended up doing. So these are 3 big topics that come up as you will work in projects, and I wanted you to be prepared to look into them. But that's all we're going to go over today, is you've learned how to create a Git repository, make changes to it locally, and then sync those changes with the remote so that you can collaborate with someone. With that, go ahead and create new projects. See ya, nerds!